We are now going to move on to more sophisticated operations known as inner product and vector norms. These are actually two different chapters in my textbook or the draft manuscript. So the definition that we're going to start with is definition 2.9, and this is called inner product between vectors. All right. Could you guess what we need to start with in order to define an inner product between two vectors? Two vectors, and we're going to start with column vectors of the same size. Then the inner product, and I want to call it an inner product. I don't want to call it a dot product. This is no longer Math 1C. Between x and y is, now I'm going to write x dot y, and then this would be, if we look at this is x1, x2, all the way down to xn, and then this is dotted with y1, y2, all the way down to yn. How would I know that that dot represents an inner product and not a scalar vector product? Because we are training ourselves to see dimensions. An inner product exists between two vectors of the same size. A scalar vector product exists between a scalar and a vector. Those are things we should confirm. Chris?
Wouldn't it get super confusing once you've got like 10 different terms and they're all different like shapes, like they're all different rows of column vectors? Some mean.
What was my statement? Every single time that you write any matrices or vectors down on a page, what do I want you to do specifically in my class? Write dimensions. And I want you to do it until your hand is bleeding, until your mind is sore, until you're literally about to vomit because you've done it so often. And then I want you to do it 10,000 more times. And the reason that I want you to do that is exactly your statement. Most linear algebraists don't, I've never had somebody tell me you should do this, and yet some of the best numerical linear algebraists in the world that I used to work with, they just see dimensions. It's part of how we look at the world. And we don't, it's like a cross check, but the reason that we do that is somewhere in our training we've spent a lot of time differentiating between the different multiplications that exist, what's on one side, what's on the other, what are the sizes, and that it will immediately tell us where we are and what we're doing. So for us, in this class, I'm going to train you all to write the dimensions down explicitly until you can't help but see them. And yes, you are correct. This gets very confusing. What is the remedy for that headache? Yeah, conscious consideration, right? So could you guess what the inner product is? x1 times y1 plus x2 times y2 plus dot 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 xn times yn. And another way to say that is we're going to sum up over all coefficients the products of the individual entries.